Welcome to another cosmic journey with exploring the universe. Picture a world that seems to have emerged from the wildest dreams of science fiction writers. A realm where diamonds fall like rain from cotton candy clouds, where storms rage for centuries across vast expanses, and where magnificent rings paint the sky in a display of celestial artistry. But this isn't the latest sci-fi blockbuster or a fantasy novel. This is Saturn, the master jeweler of our solar system, a planet that continues to captivate astronomers and dreamers alike with its otherworldly beauty. As we venture into today's exploration, we'll peel back the layers of mystery surrounding this majestic gas giant. We'll uncover secrets that challenge everything we thought we knew about planetary physics, and discover how this remarkable world holds clues to our own cosmic origins. From its shimmering rings to its turbulent atmosphere, every aspect of Saturn tells a story of the universe's incredible complexity. But before we dive deeper into these cosmic mysteries, here's something that might blow your mind. If you could find an ocean large enough, Saturn would actually float. Yes, you heard that correctly. Despite being the second largest planet in our solar system, this celestial behemoth is less dense than water. Imagine that, a planet so massive it could fit over 760 Earths inside it, yet it would bob like a cosmic rubber duck in a cosmic bathtub. But this fascinating fact is just the beginning of the wonders that Saturn has in store for us today. If you're already intrigued by these cosmic revelations and can't wait to learn more about the secrets of our solar system, take a moment to hit that like button. And don't forget to subscribe to Exploring the Universe, where we embark on mind-bending journeys through space and time every week. Trust me, you won't want to miss what's coming next as we unravel the mysteries of the universe together. Now, let's begin our journey to understand this magnificent ringed world that has captured humanity's imagination for centuries. Let's begin our exploration of Saturn, truly the crown jewel of our solar system. As we venture outward from our Sun, past Mercury, Venus, Earth, Mars, and Jupiter, we arrive at this magnificent world, the sixth planet from our star. While Jupiter may claim the title of largest planet, Saturn stands as a close second, commanding respect with its breathtaking presence in the cosmic dance of our solar neighborhood. But what exactly is Saturn made of? Unlike the rocky worlds of the inner solar system, Saturn belongs to a different class of planets altogether. This gas giant is primarily composed of the two most abundant elements in the universe, hydrogen and helium, the same basic ingredients that make up our Sun. If you were to attempt to land on Saturn, you'd find an impossible task ahead of you. There's no solid surface to touch down on. Instead, you'd encounter layers upon layers of gases that gradually become denser as you travel deeper into the planet's atmosphere, eventually transitioning into a liquid state under immense pressure. The sheer scale of Saturn is mind-boggling. Picture our Earth, the only home we've ever known, and multiply its size by 9. That's how massive Saturn is. Yet, here's where things get truly fascinating. Despite its enormous size, Saturn is surprisingly light for its volume. In fact, it's the least dense planet in our solar system, with a density only about 1/3 that of Earth. To put this in perspective, imagine filling a bathtub with water. Saturn would float in that bathtub if it were large enough. This remarkably low density is due to its composition of lightweight elements and its rapid rotation, which causes the planet to bulge at its equator. This combination of immense size and low density creates a world that defies our earthbound expectations. Saturn's appearance from space reveals bands of swirling clouds and subtle shades of yellow, brown, and gold, created by fierce winds that can reach speeds of up to 1,600 kilometers per hour. These characteristics make Saturn not just a physical giant in our solar system, but also one of its most visually striking and scientifically intriguing members. The planet's unique properties, its position, composition, and physical characteristics, all work together to create a world that has captured human imagination since Galileo first turned his telescope toward it in 1610. Yet, what we see from Earth is just the beginning of Saturn's story, as this majestic world holds many more secrets within its swirling clouds and beyond. Now, let's turn our attention to perhaps the most spectacular feature of Saturn, its magnificent ring system. When Galileo first observed these structures in 1610 with his primitive telescope, he thought they were moons or some kind of ears attached to the planet. It wasn't until 1655 that Dutch astronomer Cassini-Huygens correctly identified them as a ring system. But even that basic understanding barely scratches the surface of what we now know about these remarkable structures. Let's start with what these rings are actually made of. Picture a vast collection of cosmic debris, ranging from the tiniest ice crystals, no larger than a grain of sand, to massive chunks of rock and ice the size of suburban houses. The majority of this material is water ice, pristine, crystalline ice that reflects sunlight brilliantly, giving the rings their characteristic bright appearance. Mixed in with the ice are bits of rocky material, dust, and even trace amounts of organic compounds. These particles dance together in an intricate orbital ballet, each piece moving at its own speed around Saturn. The scale of Saturn's rings is almost impossible to comprehend. If we were to stretch them out from Earth, they would span more than 2/3 of the distance between our planet and the Moon. That's an astounding 280,000 kilometers. Yet, here's what makes these rings truly remarkable. Despite their vast expanse, they are incredibly thin. Most places in the ring system are only about 10 meters thick, proportionally thinner than a sheet of paper. Imagine spreading a piece of paper across a football field. That's roughly the same ratio of thickness to width that we see in Saturn's rings. The origin of these magnificent rings remains one of the most intriguing mysteries in planetary science. Current theories suggest two main possibilities, both equally fascinating. The first theory proposes that the rings are the remnants of one or more moons that strayed too close to Saturn and were torn apart by the planet's intense gravitational forces. These destroyed moons would have been shredded into countless pieces, spreading out into the ring system we see today. The second theory suggests that the rings are made of leftover material from Saturn's formation period, primitive debris that never coalesced into moons, instead remaining trapped in orbit around the giant planet. Recent observations from NASA's Cassini mission have added another layer of intrigue to this story. The rings appear to be relatively young, perhaps only 100 million years old, which is quite young compared to Saturn's age of about 4.5 billion years. This suggests they might have formed when dinosaurs still roamed the Earth. The rings are also dynamic, constantly changing and evolving. They're not silent or static. They're alive with waves, ripples, and even what scientists call propellers, which are disturbances in the rings caused by the gravitational effects of small moonlets. The rings are also divided into distinct sections, each with its own character. The main rings, labeled A through G, show varying levels of density and composition. There are mysterious dark spokes that appear and disappear, gaps where moons have cleared paths, and places where the rings clump together in fascinating patterns. The Cassini division, the largest and most noticeable gap in the rings, spans nearly 5,000 kilometers, a testament to the complex gravitational dynamics at play in this system. These magnificent rings serve as a natural laboratory for understanding how solar systems form and evolve. They demonstrate principles of gravity, orbital mechanics, and particle dynamics that help us understand not just Saturn, but other planetary systems throughout the universe. As we continue to study them, Saturn's rings keep revealing new secrets, reminding us that even in our own cosmic backyard, there are still countless mysteries waiting to be unraveled. While Saturn's rings might steal the spotlight, its collection of moons tells an equally compelling story of wonder and possibility. Among more than 80 confirmed moons orbiting this gas giant, two stand out as particularly fascinating: Titan and Enceladus. These worlds are so remarkable that they've become prime targets in humanity's search for life beyond Earth. Let's first journey to Titan, Saturn's largest moon, and a world that defies our expectations of what a moon should be. Larger than the planet Mercury, Titan is the only moon in our entire solar system wrapped in a thick, complex atmosphere. This atmosphere, primarily composed of nitrogen, creates a remarkable similarity to Earth's air, though considerably colder. But what makes Titan truly extraordinary is what lies beneath these alien clouds. Imagine standing on Titan's surface. Through its orange-tinted atmosphere, you'd witness something unprecedented in our solar system, the only world besides Earth with stable liquid on its surface. But instead of water, Titan's seas and lakes are filled with liquid methane and ethane. These hydrocarbon seas, with names like Kraken Mare and Ligeia Mare, create a bizarre yet familiar landscape of coastlines, islands, and even seasonal changes. Scientists have observed what appears to be methane rain, complete with weather patterns that mirror Earth's water cycle, but at temperatures of about -179 degrees Celsius. Beneath Titan's icy crust lies another surprise, a global ocean of liquid water mixed with ammonia. This combination of organic compounds on the surface and liquid water beneath makes Titan a potential candidate for harboring some form of life, though it would likely be very different from anything we know on Earth. The Dragonfly mission, scheduled to launch later this decade, will explore this mysterious world, becoming the first vehicle to fly in the atmosphere of a world in our outer solar system. Now let's turn our attention to Enceladus, a much smaller moon that has revolutionized our understanding of where life might exist in our solar system. At first glance, this ice-covered world might seem unremarkable. It's only about 500 kilometers in diameter, roughly the distance from London to Paris. However, in 2005, NASA's Cassini spacecraft made a discovery that would change everything: giant geysers of water vapor erupting from Enceladus's south polar region. These aren't just any geysers. They're massive plumes of water ice and vapor shooting hundreds of kilometers into space through cracks in the moon's icy surface, nicknamed tiger stripes. When Cassini flew through these plumes, it detected organic compounds, carbon dioxide, and most importantly, molecular hydrogen, a potential food source for microorganisms. This evidence strongly suggests the presence of hydrothermal activity on the ocean floor of Enceladus, similar to the deep-sea vents on Earth that support thriving ecosystems. What makes Enceladus even more intriguing is that all the ingredients needed for life as we know it are present: liquid water, organic compounds, and a source of energy. The global ocean beneath its icy crust is kept liquid by tidal heating, the gravitational push and pull from Saturn that generates internal heat. This mechanism creates a potentially habitable environment that has persisted for possibly billions of years. The discovery of these active processes on Enceladus has made it one of the most promising places to search for life beyond Earth. Unlike Europa, Jupiter's icy moon, or Titan, Enceladus literally ejects samples of its subsurface ocean into space, making it relatively easy to study its internal composition without having to drill through kilometers of ice. These two moons, Titan and Enceladus, represent some of the most exciting destinations for future exploration in our solar system. They challenge our understanding of where life might exist and what forms it might take. As we continue to study these worlds, they remind us that the universe might be far more interesting and full of possibilities than we ever imagined. In the coming decades, these moons might just help us answer one of humanity's most profound questions: are we alone in the universe? Among all the wonders that Saturn presents to us, some of its most bizarre and captivating features are its extraordinary atmospheric phenomena. Let's explore two of the most remarkable: the mysterious polar hexagon and the Great White Storm, atmospheric features that showcase the sheer scale and complexity of this giant world. Let's begin with one of the most perplexing mysteries in our solar system: Saturn's polar hexagon. Imagine looking down at Saturn's North Pole and seeing something that seems almost artificially designed: a perfect hexagonal-shaped weather pattern, as if someone had used a cosmic geometrical ruler to draw it. This six-sided jet stream rotates around the North Pole with winds reaching speeds of about 320 kilometers per hour. But what makes this feature truly mind-boggling is its size. The hexagon spans roughly 30,000 kilometers across, wide enough to fit nearly 4 Earths inside it. This hexagonal storm has persisted for at least 4 decades, as long as we've been able to observe it, and possibly much longer. Scientists first discovered it during the Voyager missions in the early 1980s, and it has remained remarkably stable ever since. Each side of the hexagon is longer than Earth's diameter, and the storm extends deep into Saturn's atmosphere. The persistence and geometric precision of this weather pattern challenges our understanding of atmospheric dynamics. While we observe various storms and weather patterns on other planets, nothing quite like this hexagon exists anywhere else in our solar system. The mystery deepens when we consider that this structure maintains its hexagonal shape despite the turbulent nature of Saturn's atmosphere. Scientists believe it's formed by a complex interaction between different rotating air masses and jet streams, but the exact mechanism that keeps it so precisely six-sided remains a subject of intense scientific debate. Even more intriguingly, the hexagon changes color with Saturn's seasons, shifting from a bluish hue during the winter to a golden color as spring arrives at Saturn's North Pole. But Saturn has another atmospheric trick up its sleeve: the Great White Storm, also known as Saturn's Great White Spot. Unlike the persistent hexagon, this is a periodic phenomenon that occurs approximately every 30 Earth years, roughly coinciding with Saturn's year. When it appears, it's one of the most spectacular shows in the solar system. The most recent Great White Storm occurred in 2010, and it was a truly magnificent spectacle. Starting as a small bright spot, it rapidly grew into a storm system that eventually wrapped around the entire planet. Picture a thunderstorm so massive that it encircles a world 9 times larger than Earth. The storm raged for more than 7 months, with lightning bolts thousands of times more powerful than those on Earth, and cloud systems reaching heights of about 200 kilometers above Saturn's cloud tops. What makes these storms particularly fascinating is their periodicity. They tend to occur roughly every Saturn year, 29.5 Earth years, usually appearing in Saturn's northern hemisphere. Scientists believe this timing is linked to seasonal changes in Saturn's atmosphere, much like how thunderstorm season occurs on Earth, but on a much grander scale. The energy released during these storms is phenomenal, enough to power the entire United States for several years if we could somehow harness it. These massive storms provide crucial information about Saturn's atmospheric dynamics. They reveal details about the planet's deep atmosphere, its energy distribution, and how different layers of its atmosphere interact. The 2010 storm was particularly valuable for scientific study because it was the first one to occur during the presence of modern observational technology, allowing scientists to study it in unprecedented detail. The existence of both the polar hexagon and the Great White Storm demonstrates how Saturn continues to surprise and puzzle us. These phenomena operate on scales that dwarf anything we experience on Earth, yet they follow physical laws that we're still working to understand. They remind us that despite all we've learned about our solar system, there are still many mysteries to solve and wonders to explain. As we continue to observe and study these features, they provide valuable insights into not just Saturn's weather patterns, but into the broader understanding of planetary atmospheres throughout the universe. If these cosmic revelations about Saturn have left you as awestruck as I am, why not take a moment to show your appreciation for the wonders of the universe by hitting that like button? And if you're eager to continue exploring the cosmos with us, don't forget to subscribe to our channel. We've got so many more fascinating space stories to share. Now let's dive into one of the most elegant astronomical phenomena, the gravitational ballet that takes place between Saturn, Jupiter, and Saturn's numerous moons. This cosmic dance is a masterpiece of celestial mechanics that has been performing for billions of years. Picture Saturn and Jupiter as two cosmic giants performing an intricate waltz across the solar system. Despite being hundreds of millions of kilometers apart, these gas giants are locked in a fascinating gravitational relationship. Their mutual gravitational pull helps stabilize each other's orbits around the Sun, creating what astronomers call a resonance pattern. This relationship is so precise that for every 5 orbits Jupiter makes around the Sun, Saturn completes almost exactly 2 orbits. This 5:2 resonance isn't just a cosmic coincidence, it's a crucial factor in maintaining the stable architecture of our outer solar system. This gravitational partnership between Saturn and Jupiter has profound implications for our entire solar system. Together, they act as cosmic shepherds, their combined gravitational influence helping to protect the inner solar system, including Earth, from potential impacts by deflecting or capturing wandering asteroids and comets. This protective role has been vital in creating the stable environment that allowed life to evolve on our planet. But Saturn's gravitational influence doesn't stop there. Closer to home, the ringed planet conducts an even more complex orchestra with its numerous moons. Like a master conductor, Saturn's powerful gravitational field orchestrates the movements of its satellite family in a series of intricate orbital resonances. These resonances occur when the orbital periods of different moons form simple numerical ratios, creating a synchronized cosmic ballet. Take, for example, the fascinating relationship between 3 of Saturn's moons, Enceladus, Dione, and Mimas. For every 2 orbits Enceladus completes, Dione completes exactly 1 orbit. This 2:1 resonance helps maintain Enceladus's orbital eccentricity, which in turn generates the internal heating that powers its famous water geysers we discussed earlier. It's a perfect example of how gravitational interactions can have direct physical consequences on planetary bodies. Similarly, the gaps and structures within Saturn's rings are largely created by gravitational resonances with nearby moons. The famous Cassini division, the largest gap in Saturn's rings, is maintained by a resonance with the moon Mimas. As ring particles enter this region, Mimas's regular gravitational nudges eventually push them out, keeping the gap clear. Even more fascinating is how these resonances can create visible waves in the rings, much like the ripples you might see when dropping stones in a pond. These waves, some of which can spiral for thousands of kilometers, are like frozen records of gravitational interactions, allowing scientists to study the complex dynamics of Saturn's system. This gravitational choreography is not just beautiful, it's essential for the stability of Saturn's entire system. The precise timing of these orbital dances helps prevent collisions between moons, maintains the structure of the rings, and even contributes to geological activity on some of Saturn's moons. It's a testament to the incredible precision and complexity of celestial mechanics, demonstrating how gravity, the weakest of all fundamental forces, can orchestrate a dance that has continued for billions of years. Understanding these gravitational interactions helps us not only comprehend our own solar system better, but also provides crucial insights into how other planetary systems throughout the galaxy might behave. As we discover more exoplanetary systems, the lessons learned from studying Saturn's gravitational relationships become increasingly valuable in understanding how planetary systems form and maintain stability over cosmic timescales. As we continue our cosmic exploration, let's put Saturn's immense scale into perspective by comparing it to our home planet, Earth. The contrasts between these two worlds not only highlight the incredible diversity of our solar system, but also provide crucial insights into how our cosmic neighborhood formed and evolved. Let's start with the most striking difference: size. Saturn is simply enormous compared to our planet. If you could hollow out Saturn and start filling it with Earths, you'd need about 764 of them to fill its volume completely. To visualize this, imagine a basketball representing Saturn and a tiny pea representing Earth. That's roughly the scale difference we're talking about. Saturn's equatorial diameter spans about 120,536 kilometers, while Earth's is just 12,742 kilometers. Yet despite this massive size difference, Saturn's surface gravity is only about 1.07 times stronger than Earth's, due to its much lower density. The differences become even more fascinating when we look beneath the surface of these two worlds. Earth, as we know it, is a rocky planet with distinct layers: a solid inner core, a liquid outer core, a mantle, and a thin crust where we live. We can walk on Earth's surface, build structures, and dig into its ground. Saturn, however, tells a completely different story. It has no solid surface to speak of. Instead, it transitions gradually from gas to liquid as you travel deeper into its atmosphere. Saturn's internal structure is like a cosmic layer cake. Its uppermost layers consist primarily of molecular hydrogen and helium, similar to the Sun's composition. As you descend deeper, the immense pressure transforms the hydrogen into a liquid metallic state, a form of matter we can barely recreate in laboratories on Earth. At its center, Saturn likely has a relatively small rocky core, perhaps about the size of Earth, but this core is surrounded by layers of metallic and liquid hydrogen, creating a structure utterly alien to our earthly experience. Temperature is another striking contrast. While Earth's average surface temperature is a comfortable 15 degrees Celsius, Saturn's outer atmosphere plunges to around minus 178 degrees Celsius. Yet, counterintuitively, temperatures in Saturn's upper atmosphere can reach a scorching 57 degrees Celsius due to a combination of solar heating and internal heat from the planet itself. What makes these comparisons particularly valuable is what they teach us about the formation of our solar system. Saturn, along with the other gas giants, is thought to have formed in a fundamentally different way than rocky planets like Earth. While Earth was built up from the collision and accretion of rocky planetesimals, Saturn likely began as a rocky core several times more massive than Earth, which then rapidly accumulated vast amounts of gas from the solar nebula, the cloud of gas and dust that surrounded our young sun. This process of formation helps explain why we find gas giants like Saturn in the outer solar system and rocky planets like Earth closer to the sun. The intense solar winds in the early solar system would have blown away most of the lighter elements from the inner regions, leaving only heavier, rocky materials to form planets like Earth. Meanwhile, in the colder outer regions, gases could accumulate around rocky cores, allowing planets like Saturn to grow to their enormous sizes. Saturn's composition also provides crucial clues about the distribution of elements in the early solar system. The ratio of elements found in Saturn's atmosphere, particularly the proportion of noble gases like helium, helps astronomers understand how materials were distributed throughout the solar nebula and how they were incorporated into forming planets. Moreover, Saturn's system of rings and moons serves as a miniature model of how the solar system itself formed. The processes we observe in Saturn's rings, accretion, collision, and gravitational interactions, are similar to those that shaped our entire solar system. By studying these ongoing processes around Saturn, we can better understand how our own planet and its neighbors came to be. The Cassini-Huygens mission was a masterpiece of international cooperation and engineering achievement. Launched in 1997, this joint NASA spacecraft embarked on a 7-year journey to reach Saturn, finally arriving in 2004. What followed was a 13-year odyssey that revolutionized our understanding of the Saturnian system. The mission was actually 2 spacecraft in one: Cassini, the orbiter, and Huygens, a probe designed to land on Titan. Together, they weighed about 5.6 tons and were roughly the size of a small school bus. The mission's achievements are nothing short of extraordinary. In January 2005, the Huygens probe accomplished something unprecedented. It landed on Titan, becoming the most distant landing ever achieved by human technology. As it descended through Titan's thick atmosphere, it captured images and data that revealed a world with Earth-like features: river channels, lakes, and seas, though filled with liquid methane rather than water. The probe even recorded the sound of Titan's winds, the first alien sounds ever recorded on another world. Meanwhile, Cassini continued its exploration of the Saturn system, completing 294 orbits around the planet. The spacecraft's discoveries were revolutionary. It found geysers of water ice erupting from the south pole of Enceladus, revealing the presence of a subsurface ocean and making this small moon one of the most promising places to search for extraterrestrial life. It captured unprecedented views of Saturn's rings, revealing their complex structure and dynamics in stunning detail. Perhaps most intriguingly, Saturn's role in protecting the inner solar system through its gravitational influence may have been crucial in allowing Earth to develop and maintain stable conditions for life. Along with Jupiter, Saturn helps shepherd potentially dangerous comets and asteroids away from the inner solar system, reducing the frequency of major impacts that could have disrupted Earth's evolution. The stark differences between Saturn and Earth remind us of the incredible diversity within our solar system, while their interconnected histories and relationships highlight the delicate balance that allowed our planet to become the life-bearing world we know today. As we continue to study both worlds, we gain deeper insights into our cosmic origins and perhaps our future among the stars. Our journey to understand Saturn has been one of humanity's greatest scientific adventures, with the Cassini-Huygens mission standing as one of the most successful and enlightening space explorations ever undertaken. Let's dive into this remarkable story of discovery and look ahead to what the future might hold. The Cassini-Huygens mission was a masterpiece of international cooperation and engineering achievement. Launched in 1997, this joint NASA spacecraft embarked on a 7-year journey to reach Saturn, finally arriving in 2004. What followed was a 13-year odyssey that revolutionized our understanding of the Saturnian system. The mission was actually 2 spacecraft in one: Cassini, the orbiter, and Huygens, a probe designed to land on Titan. Together, they weighed about 5.6 tons and were roughly the size of a small school bus. The mission's achievements are nothing short of extraordinary. In January 2005, the Huygens probe accomplished something unprecedented. It landed on Titan, becoming the most distant landing ever achieved by human technology. As it descended through Titan's thick atmosphere, it captured images and data that revealed a world with Earth-like features: river channels, lakes, and seas, though filled with liquid methane rather than water. The probe even recorded the sound of Titan's winds, the first alien sounds ever recorded on another world. Meanwhile, Cassini continued its exploration of the Saturn system, completing 294 orbits around the planet. The spacecraft's discoveries were revolutionary. It found geysers of water ice erupting from the south pole of Enceladus, revealing the presence of a subsurface ocean and making this small moon one of the most promising places to search for extraterrestrial life. It captured unprecedented views of Saturn's rings, revealing their complex structure and dynamics in stunning detail. The images returned by Cassini were breathtaking. It captured the famous pale blue dot image of Earth seen through Saturn's rings, showing our planet as a tiny point of light billions of kilometers away. It photographed Saturn's rings during equinox, when the sun's light hit them edge-on, revealing three-dimensional structures and shadows we'd never seen before. The spacecraft even captured detailed views of Saturn's polar hexagon and witnessed the development and evolution of the Great White Storm of 2010 to 2011. But perhaps most remarkably, Cassini provided us with data about Saturn's moons that transformed our understanding of where life might exist in our solar system. The discovery of organic compounds in Enceladus's plumes and the detailed mapping of Titan's seas and lakes opened up new possibilities for finding life beyond Earth. The mission came to a dramatic end on September 15, 2017, when Cassini plunged into Saturn's atmosphere in what NASA called the grand finale. This deliberate crash was designed to protect potentially habitable moons from contamination and allowed the spacecraft to gather unprecedented data about Saturn's atmosphere during its final moments. Looking to the future, several exciting missions are in development to explore Saturn's most intriguing moons. NASA's Dragonfly mission, scheduled to launch in 2027, will send a nuclear-powered rotorcraft to explore Titan. This remarkable vehicle will be able to fly through Titan's thick atmosphere, sampling the moon's complex organic chemistry and visiting multiple sites across its diverse surface. It will be able to cover more distance in a few hours than all of NASA's Mars rovers combined have covered in several years. There are also proposals for missions to Enceladus, including concepts for spacecraft that could fly through its plumes to sample their composition directly. Some scientists have even proposed sending submarines to explore Titan's methane seas, or specialized probes to investigate Enceladus's subsurface ocean through its ice cracks. While these future missions are still in various stages of planning and development, they represent humanity's continued fascination with Saturn and its moons. The knowledge gained from Cassini-Huygens has opened up new questions and possibilities that these future missions will help us explore. One particularly exciting possibility is the potential for detecting signs of life. Both Titan and Enceladus are now considered prime candidates in our search for extraterrestrial life, though any life forms there would likely be very different from what we know on Earth. Future missions will be equipped with sophisticated instruments specifically designed to detect potential biosignatures. As we look forward to these future explorations, we can only imagine what new discoveries await us in the Saturnian system. The legacy of Cassini-Huygens continues to inspire new generations of scientists and engineers, driving us to push the boundaries of what's possible in space exploration. Each new mission brings us closer to answering fundamental questions about our cosmic neighborhood and our place within it. Throughout human history, Saturn has captured our imagination and played a significant role in our cultural development, from ancient mythology to modern science fiction. Let's explore how this magnificent planet has influenced human culture across the ages. In Roman mythology, Saturn was one of the most important deities, known as the god of time, agriculture, abundance, and social order. The Romans knew him as Saturnus, but his origins trace back to the Greek god Kronos. According to legend, Saturn ruled over the golden age of humanity, a mythical time of peace, prosperity, and equality. During this period, humans lived like gods, free from toil, pain, and the ravages of old age. This association with a golden era led to the annual festival of Saturnalia, one of Rome's most important celebrations, where social norms were temporarily reversed, slaves dined with their masters, and gifts were exchanged, a tradition that influenced modern Christmas celebrations. The planet's association with time, as Saturn/Kronos was often depicted carrying a sickle or hourglass, continues to influence our culture today. The English word Saturday derives directly from Saturn's name, and in astrology, Saturn represents discipline, responsibility, and life lessons, reflecting its slow, methodical orbit around the Sun. In the realm of early astronomy, Saturn holds a special place in scientific history. When Galileo Galilei first observed Saturn through his telescope in 1610, he was bewildered by what he saw. His primitive telescope wasn't powerful enough to clearly show the rings, leading him to describe the planet as having ears or being triple-bodied. He wrote in his notes, "I have observed the highest planet triple-bodied." This is to say that to my very great amazement, Saturn was seen to me to be not a single star, but three together, which almost touch each other. This mysterious appearance puzzled astronomers for decades until Cassini-Huygens correctly identified the rings in 1655, using a more powerful telescope. The discovery of Saturn's rings marked a pivotal moment in human understanding of the cosmos. It showed that the universe contained structures unlike anything we knew on Earth, expanding our conception of what was possible in nature. This revelation has continued to inspire scientists and artists alike for centuries. In modern popular culture, Saturn has become an iconic symbol of space exploration and the mysteries of the cosmos. Its distinctive appearance with its magnificent rings has made it probably the most recognizable planet in our solar system, appearing countless times in artwork, logos, and visual representations of space. From children's first drawings of the solar system to sophisticated astronomical art, Saturn's rings make it instantly identifiable and captivating. In science fiction, Saturn and its moons have served as settings for numerous stories and adventures. Arthur C. Clarke's 2001, A Space Odyssey, features a famous journey to Jupiter in the film version, but in the novel sequel, 2010, Odyssey 2, Saturn and its moon Iapetus play crucial roles. Kim Stanley Robinson's 2312 depicts human colonies throughout the solar system, including settlements in Saturn's rings. The moon Titan, with its thick atmosphere and liquid methane seas, has particularly captured authors' imaginations, appearing in works like John Varley's Titan trilogy and Stephen Baxter's Titan. Visual artists have also found endless inspiration in Saturn's beauty. The planet has been depicted in countless paintings, digital artworks, and sculptures. Space artists like Chesley Bonestell helped shape our visual understanding of Saturn before space probes provided actual images, creating dramatic paintings that combined scientific accuracy with artistic vision. His work, along with others, influenced how we imagine space exploration might look and helped build public support for space programs. In music, Saturn has inspired various compositions, most famously Saturn, the bringer of old age, from Gustav Holst's orchestral suite, The Planets. Modern musicians continue to reference Saturn in their work, particularly in space-themed electronic and ambient music. The planet has also influenced architecture and design. The distinctive shape of its rings has inspired buildings, sculptures, and logos, particularly for space-related organizations and companies. The visual impact of Saturn's rings makes it a powerful symbol of space exploration and scientific discovery. Even in modern digital culture, Saturn maintains its cultural significance. It appears in countless video games, often as a setting for futuristic mining operations or alien encounters. Social media and digital art platforms are filled with both realistic and artistic interpretations of the planet, showing how it continues to captivate new generations. This enduring cultural presence of Saturn, from ancient mythology through the scientific revolution and into modern popular culture, demonstrates its unique ability to inspire human creativity and wonder. As we continue to learn more about this magnificent world through scientific exploration, it seems certain that Saturn will continue to influence our cultural imagination for generations to come. Saturn, with its unparalleled beauty and staggering scale, serves as a cosmic puzzle, continually challenging our perceptions and inspiring humanity's innate curiosity. Its rings, vast and delicate, stretch out in patterns that seem almost crafted by an artist's hand, while its moons each tell a story of their own, hinting at secrets hidden within their icy surfaces and thick atmospheres. Every telescope pointed at Saturn, every probe that draws near, brings us closer to understanding this planet's unique place in the celestial order. In Saturn, we see a glimpse of the forces that shape not only our solar system, but potentially countless others, each obeying universal principles of gravity, motion, and creation. It's more than just a planet. It's a testament to the intricate design that underpins the entire cosmos. Our fascination with Saturn isn't just scientific, it's profoundly existential. The more we learn about it, the more it challenges us to ask questions about our own place in the universe. Are there other worlds around distant stars with ring systems just as breathtaking? Could there be life lurking in the icy depths of moons like Titan and Enceladus, where the building blocks for life might already be present? The potential discoveries waiting for us around Saturn are as infinite as the universe itself, reminding us that even in our closest celestial neighbors, there are still profound mysteries to solve. Every detail of Saturn, from its storms and gravitational dances with Jupiter to its potential as a life-harboring system, invites us to explore deeper and dream bigger. As our technology advances, the possibilities become even more thrilling. Imagine a future where humanity reaches beyond Earth's orbit to set foot on Saturn's moons, where we might stand on the shores of Titan's methane lakes or watch geysers erupt on Enceladus, flinging water vapor and organic compounds into space. What we observe today from afar could one day be within our grasp, transforming what was once imagination into real-life exploration. Saturn symbolizes the future of human discovery, a place where science and dreams converge, revealing not only the universe's mysteries, but also our potential to understand them. If you're as captivated by Saturn as we are, don't let your journey end here. Give this video a like, share it with friends who wonder about the cosmos, and subscribe to Exploring the Universe. Together, let's keep pushing the boundaries of knowledge, venturing farther into the unknown, and discovering what lies beyond the stars. Until our next cosmic journey, keep looking up, because the universe is waiting to be explored.